Hi, in this module, let us look at some of the standalone artificial intelligence technologies. Here, by standalone, we mean non-hosted solutions. These are products that can be run on individual computers. So you could power them up on your own laptop computer and work on them to building your machine learning or artificial intelligence applications. These products could also be deployed on your own servers and sometimes can also be set up into a cluster. This module does not offer an exhaustive coverage of the entire landscape, but we have covered few that you may find useful. Let us start with the MLib library supported by Apache Spark. Spark basically started off to be known as part of the Hadoop ecosystem. However, it has ever since been born outside of the Hadoop framework. Simply put, Spark is an in-memory processing system supporting low-latency analytics over data primarily stored in memory. It today has a name of its own outside of the Hadoop ecosystem. With some of the new advances, Spark has actually become a go-to machine learning framework. The MLib package available within Spark ships with several rich and ready-to-use machine learning algorithms. It offers a growing library of machine learning algorithms that can be applied to in-memory data at high speeds. Last year's release of version 1.5 added many new algorithms, improved existing ones, and further bolstered MLib support in Python. Apache Singa offers deep learning frameworks that power heavy-duty machine learning functions such as natural language processing and image recognition. Singa provides a simple programming model for training deep learning neural networks. It encourages clustering and takes full advantages of distributed processing. It supports many common types of training jobs such as convolution neural networks, restricted Boltzmann machines, and also recurrent neural networks. If you don't understand this yet, that is fine, as we will be covering some of the models in the later parts of the course. Singa models can be trained synchronously, that is one after the other, or asynchronously, which is side by side. Singa works with Zookeeper to greatly simplify cluster setup and supports seamless execution over a cluster. Caffe is another deep learning framework. Caffe is made by keeping in mind the need for expression, speed, and modularity. Caffe was originally developed in 2013 for machine vision projects. Since then, it has now expanded to include other applications as well in the field of speech and multimedia. Caffe is designed keeping speed requirements in mind. It supports GPU accelerated computing as well as CPU-based computing. GPU acceleration allows Caffe to execute thousands of threads in parallel using the machine's GPU capabilities. Caffe is entirely written in C++, and the language was chosen primarily to get the best possible speed of execution. Caffe supports CUDA acceleration for GPU-based processing, which further enhances Caffe speed. The Caffe distribution includes a set of free and open source reference models for common classification jobs, along with other models created and donated by the Caffe user community. Google's TensorFlow is a machine learning framework designed to scale across multiple nodes. TensorFlow was built to solve problems internally at Google. Google then eventually elected to open source TensorFlow. TensorFlow implements what are called data flow graphs. Your batches of data, called tensors, can be processed by a series of algorithms described by a graph. The movement of the data through the system are called flows, hence the name TensorFlow. The graphs can be assembled with C++ or Python and can be chosen to process over CPU or GPUs. MATLAB, combined with Simulink, offers an exhaustive suite of technologies for research, simulation, and analytics. Amongst other rich libraries, MATLAB ships with a machine learning package. It offers pre-built functions, extensive toolboxes, and specialized apps for classification, regression, and clustering. With MATLAB, you can compare approaches such as logistic regression, classification trees, support vector machines, ensemble methods, and even deep learning. You can also use model refinement and reduction techniques to create an accurate model that best captures the predictive power of your data. MATLAB also helps integrate machine learning models into enterprise systems, clusters, and clouds. It also helps target models to real time embedded hardware. There are several other technologies as well, some popular while some not so popular. Bear in mind that we are not endorsing any of the technologies mentioned here and are not against use of any of the undermentioned technologies as well. We just chose a few technologies to give you an idea of what's there. It does not mean that the ones we mentioned are the best. You should feel free to see what technologies and products you're comfortable with and then make an appropriate choice. Throughout rest of the lectures, depending on the context, we will continue to introduce you to more and more technologies.